This class is related to the chemical reaction, and actually this is practice for the chemical reaction. These are very simple chemical reaction, and this is for beginners. And here we have some incomplete word equation. We are going to complete this, and we are going to write formula equation for this, and then we'll balance it, and we'll find the type of reaction also. Okay, look at this. Aluminium, when reacts with oxygen, then what happens? Aluminium oxide forms. Aluminium oxide forms. Now this is very simple word equation. How to convert it into a formula equation? Aluminium is represented by this way: Al plus oxygen O2, and when they combine with each other, then we'll write molecular formula of aluminium oxide. First AlO, and valency of aluminium is 3 is given to oxygen, oxygen 2 is given to aluminium. Now we have to balance this equation. Here it is 3, here it is 2. This is odd number, this is even number. That's why to balance these two, it will better to write 2 in front of the odd number, then it becomes even. 3 2s are 6, and if we take here 2, then 3 2s are 6, oxygen balance. Now 2 2s are 4. If we take here 4, this is balanced chemical equation for aluminium and oxygen. And what type of reaction is it? Two elements are combined to form a compound. That's why this is combination. This is combination reaction. This way we can declare. Now let's go to second. What we have here, potassium chlorate. When heated at high temperature, then what happens? Potassium K, chlorate means ClO3, potassium valency 1, chlorate valency 1, equal valency, no exchange. Now when it is heated at high temperature, suddenly it decomposes. This is one of the method of preparation of oxygen gas in laboratory, by heating method. And when it decomposes, then it converts to potassium chloride, potassium 1, chlorine 1, no exchange, equal valency, plus another product is oxygen. And oxygen, whenever becomes free, we have to write molecule of oxygen O2, because it is diatomic in free state. Now we are going to balance this equation. And how to balance this? Oxygen 2, oxygen 3, it is similar to the previous. If odd number, it will be better to have 2 in front of it to make it even, and then we'll balance. 3 2s are 6. Now if I take here 3 2s are 6, it is balanced. Now chlorine, here it is 1, here it is 2. That's why if I take here 2, chlorine is balanced both the side. Potassium K, 2, here also 2. So okay. Now what is the product? I haven't written the name. This is potassium chloride. Potassium chloride plus oxygen gas. Oxygen. And what type of reaction it is? This reaction is decomposition reaction, a chemical reaction in which a compound splits up into 2 or more than 2 elements or other compound, then that is called decomposition reaction. That's what this is. Decomposition reaction. Now let's go to number 3. Number 3. Ferric oxide plus hydrochloric acid. If you don't know the product, then you can go through the molecular formula. Ferric oxide first. Let's write ferric oxide. Ferric, iron having valency 3. If it was Os, then its valency is 2, but Ik means more valency, it has valency 3. Oxide means it is combined with oxygen. Now iron valency 3, oxygen 2. That's why we have to exchange the valency, plus hydrochloric acid. We have to remember its molecular formula directly, and we don't have to exchange because it is directly remembered. And what type of reaction it is, and what is the product? With this metallic oxide, metal oxide. Metallic oxide is base, but this is acid. That's why this is acid-base reaction. In acid-base reaction, One of the product is salt, another product is water. And how salt forms? Hydrogen of acid is displaced by the metal. That's why it becomes FeCl. Now here valency of iron is 3. That's why we are making ferric chloride. Iron valency 3 should be transferred to chlorine. Chlorine 1 we don't have to transfer. Plus now another product I told you, one is salt, another is water. When acid reacts with base, salt and water forms. This is the chemical reaction. This formula equation is okay, but we have to balance this. Oxygen 1, oxygen 3. Here if I take 3, then it is balanced. Now hydrogen 3 2s are 6. If we take here 6, then it is balanced. Chlorine here 3. Here chlorine is 6. That's why if I take here 2, now chlorine 3 2s are 6, balance. Iron is 2, iron is 2, is balanced chemical equation. Now I have to write the product also. It is ferric chloride. This is ferric chloride. And another product is what? Water. Ferric chloride and water. The salt and water. And what type of reaction is this? Previously I told you acid-base reaction. Acid-base reaction. Now let's go to another one. Zn plus silver nitrate. Silver is Ag. Nitrate is NO3. Valency silver 1, nitrate 1, equal valency, no exchange. Now this is distinctly displacement reaction. How? Zinc is more reactive than silver. That's why zinc displaces the silver and it forms Zn zinc nitrate NO3. Valency of zinc is 2, nitrate is 1. 1 we don't have to transfer. Zinc valency 2 of zinc is transferred to nitrate. Now silver is displaced, that's why it becomes 3. This is Ag. Now what compound form we are going to write the name? This name of this compound is zinc nitrate. Zinc nitrate. And another product is silver. Now we have to balance also. Silver 1, okay. Nitrate 2, that's why I have to take here 2. Okay, nitrate is balanced but silver is not balanced. That's why if we take here 2, it's balanced. Now zinc is 1, zinc 1. This is displacement reaction. This is actually single displacement. Let's go to question number 5. Calcium hydroxide plus nitric acid. What forms later we'll talk, but we'll write the molecular formula of this. Calcium hydroxide means CaOS. Valency of calcium is 2, hydroxide is 1. That's why valency of calcium should be transferred to this hydroxide. And now another is nitric acid. Nitric acid, directly we have to remember HNO3. It's commercial name. Nitric acid. Now what happens in this reaction? This is metallic hydroxide. Here it was metal oxide base. So metallic hydroxide is also base. That's why this base is reacting with acid. So acid base reaction, one product is salt, another product is water. How salt forms? Calcium takes the place of hydrogen, CaNO3. Calcium valency 2, nitrate 1. That's why Ca valency 2 should be given to nitrate. And radical we have to keep in bracket and valency is transferred. Now another product is water. After writing this correct molecular formula, we have to balance it. Oxygen 1, here also oxygen, but I don't want to count this because nitrate is present right hand side and left hand side. Both the side will count nitrate. Oxygen 1, oxygen 2. That's why I will take here 2. Oxygen is balanced. Now hydrogen 2 2s are 4. If here 2 and 1 3, then here we have odd number. It means if we take here 2, then 2 2 4, and that's why 4 hydrogen balanced. Now oxygen also balanced. Now nitrate 2, okay. Calcium 1, okay. It is balanced. Now what the name of this calcium nitrate? Calcium nitrate plus water. Acid base reaction, salt and water formed, and this is acid base reaction. Okay, number 6, washing soda. You have to remember the name, remember the molecular formula of washing soda. This commercial name, washing soda, is Na2CO3. Actually, it is sodium carbonate. And plus magnesium chloride, magnesium Mg, chloride means Cl is combined. Magnesium valency 2, chlorine 1, that's why 1 should not be transferred, because Mg itself is 1, magnesium 2 is transferred to chlorine. Now this is, looking at this, what can we say? This double displacement reaction. Sodium takes the place of magnesium, magnesium takes the place of sodium. That's why this is double displacement. And if magnesium takes the place of sodium, then what happens? MgCO3, magnesium valency 2, carbonate valency 2, equal valency, no exchange. Plus now sodium takes the place of magnesium. I'm writing NaCl. Now you have to remember that Y2 is not taken here. Y2 of chlorine is not taken here, because this 2 came by the transfer of valency of carbonate to sodium, and this 2 also valency of magnesium. But we are writing another compound, and new exchange of valency now takes place. That's why sodium valency 1, chlorine valency 1, equal valency, no exchange. So this is correct molecular formula, and formula equation is now ready, but we have to balance it. Chlorine 1 here, here chlorine 2, that's why it is better to have chlorine here too. Sodium 2, sodium 2, okay. Carbonate 1, carbonate 1, okay. Magnesium 1, magnesium 1, okay. Now this name of this compound is magnesium carbonate. Magnesium carbonate. And another product is what? Another product is sodium chloride. Sodium chloride. And what type of reaction it is? It is double displacement reaction, because one of the element of one compound is displaced by another element, and again the another element of another compound is displaced by second element of second compound. That's why this is double displacement. So we can say just displacement. If you are told to differentiate double or single, then you can say double displacement. Now question number 7. What is it? Quicklime plus water. The product is also given. It's okay. Slackline. You have to identify what compound it is. Quicklime means calcium oxide, and its valency is 2 to equal valency, no exchange, plus water S2O. And slackline means CaOS whole 2. CaOS whole 2. Now we have to remember slackline and quicklime. Hydrogen 2, hydrogen 2, okay. Oxygen 2, oxygen 1 and 1, 2, okay. Calcium 1, calcium 1, okay. This is balanced chemical equation, so we don't have to put any number here. Okay, now what type of reaction it is? It is combination reaction. Why combination? Because a reaction in which two or more than two elements or compounds combine to form single compound, that is called combination reaction. Here quicklime is a compound, water is another compound, two compounds are combined to form another compound, calcium hydroxide. That's why this is combination reaction. Now hydrogen peroxide, number 8. When hydrogen peroxide decomposes, actually it is decomposed by using manganese dioxide as catalyst. This is the method of preparation of oxygen gas by non-heating method. This is one of the method of preparation of oxygen gas, non-heating method. And hydrogen peroxide itself decomposes into water and oxygen very slowly. Okay, this theoretical part we don't need here. Hydrogen peroxide, when decomposes, it forms water and oxygen gas. Okay, hydrogen peroxide is formula is S2O2. We have to remember this. And when it decomposes, it forms water H2O and oxygen O2. Now we have to balance this. Oxygen 2 and 1 3, here it is 2, it's odd number in right hand side. 2, and this is even, but this is odd, that's why if I take here 2, then 2 plus 2 4, and if I take here 2, 2 to the 4, hydrogen 2 to the 4, balance. This is decomposition reaction. Why? Because a compound is decomposed into two different substance. One is compound, another is element. And a chemical reaction in which a compound splits up into two or more than two elements or other compounds, then that is called decomposition reaction. That's why this is a decomposition reaction. Okay, this much for today.